So today we're learning our third method of solving systems of equations, and that is by elimination. So this solving by elimination is primarily used when equations are written in standard form, which is when they're in this form where x and y are on the same side of the equation. Okay? So whenever you see an equation written in standard form, so that would be something like 4x plus 2y equals 5, right? This would be a good clue that it's time to use elimination to eliminate one of the variables. Now, the process of elimination makes use of the concept of additive inverses. So if you look at these expressions, you notice it's -5 plus 5, 6 plus -6, -7 plus -7x plus 7x, 11x plus -11x. And what you might notice about all of them is that they all sum to 0. When you add an opposite, it cancels it, it gets rid of it. So when you add the opposite of these things, they cancel out and are gone. That is what we use for this process of elimination. We're going to use the additive inverse property to be able to eliminate a variable. But how do you pick which variable to eliminate? How do you know? What you do is, first we're going to cover the relatively simple case where we look for a variable that has the same or opposite coefficients. Right? If you have a variable where the number in front of that variable in both equations is the same, that's the one we're going to eliminate. So that means you would be looking at something like this, right? Here, 3x in one equation, a 3x in the other. If I subtract, then that eliminates the variable, right? 3x minus 3x equals 0x. If the variables have opposite coefficients, right, this means same number, different signs, right? So they have opposite coefficients, like you see 3x and -3x, then you add. By adding them, you eliminate that variable from the expression. So let's look at how this works. Okay, here's an example, and the instructions say solve the following system by elimination. So when I see elimination, I think, okay, I need to find some coefficients that are the same. So if I look here, I see I have a positive y and a negative y. They have the same coefficient. The number in both cases is 1, and they have opposite signs. One is a positive and one is a negative. Okay? So that's the one I'm going to go ahead and eliminate. And I remember when I have opposite signs, I add, right? So you see this plus sign here. I'm going to add the two equations. Adding them gives me 6x plus -5x is 1x. Y plus -y is 0y. 46 plus -35 is 11. This y term goes away, right? It's just a placeholder, and I'm left with x equals 11. By eliminating the y, I added the two equations and eliminated the y. That allowed me to solve for the x. I'm not done yet, because remember, every equation has to have two numbers to solve it. So I take that x equals 11 and I substitute it back into the original equation to solve for y. 6 times 11 is 66, plus y equals 46. When I subtract 66 from both sides, I'm left with y equals -20. So my solution is 11, -20. And remember, you can always check your solution by plugging these numbers into both equations, the first and the second, and solving to make sure that they are true statements at the end. Okay, so let's go ahead and look at another example. I have two equations here, and my instructions say solve by elimination. When I solve by elimination, my first step is to look for coefficients that are the same. In this case, my y coefficients are 1 and 3. Those are not the same. I cannot eliminate y. My x coefficients, however, are 3 and 3. So I see they have the same number. Both are 3. And they have opposite signs. So when they have opposite signs, that means I'm going to add. So I'm going to go ahead and add these two equations. 3x plus -3x leaves me with 0x. Y plus -3y gives me negative 2y. 12 plus negative 24 gives me negative 12. This 0x is just a placeholder. I don't need to keep that. Negative 2y equals negative 12. Dividing by negative 2 on both sides, I get y equals 6. I'm not done yet. Now I have to take that number and plug it in to an original equation. 3x plus 6 equals 12. Subtract 6 on both sides. 3x equals 6, or x equals 2. So my final answer is 2, 6. To check this, I plug it into both equations. 3 times 2 is 6, plus 6 equals 12. That's good. Negative 3 times 2 is negative 6. Negative 3 times 6 is negative 18. Negative 6 minus 18 is negative 24. Check, that one's good. My answer is good to go. So we can look here, just not solve the whole problem, but just to check. I see I have two options. These numbers are the same, but the signs are the same. These numbers are the same, but the signs are opposite. So I would go ahead and eliminate the y terms by adding the equations. Here, again, these numbers are the same. These have opposite signs. I would add to eliminate the y. Here, these numbers are different, but these are the same with opposite signs. Add to eliminate the x. And in this case, these x's would get canceled, and you would end up with negative 7y equals 14. And here's another case that happens. Sometimes I don't have the choice where I have the same number and opposite signs. Right? My first step is still the same. I have to choose a variable to eliminate. In this case, I see the 5 and the 2. Those aren't the same number. I see the 1 and the 1. These are the same number, but this time they have the same sign. Okay? So now let's talk about what we do when we have the same number and the same sign. There are actually two choices that end up being the same thing, just two different ways to look at it. The first method is to multiply one equation by negative 1 and then add the equation. The second method is to subtract the equations by remembering that all of the signs change. So let's look at how this plays out. Okay, so here is my system. If I take the first method and multiply my entire equation by negative 1, I remember that I have to distribute this negative 1 to every single term, and all of my signs change to 2x minus y equals 4. So now I look at this and I see by multiplying both sides, I have changed the sign. Now they have the same number, opposite signs, excuse me, and they can proceed the same way we've been practicing. The second method says, okay, just subtract all of them across. So I look 5 minus negative 2. Minus a negative is like adding, so that becomes 7. Y minus y cancels that term out. 17 minus negative 4 gives me 21. And you see, whichever way you prefer to look at it, you end up with the same answer. The reason why is that multiplying by negative 1 and adding is exactly the same thing mathematically as subtracting the entire equation. I prefer this method because I am afraid that I might forget to carry the minus sign across for a sign. So I actually like to rewrite the entire equation. So let's look at an example of doing this solution. Okay, let's solve this system by elimination. 2 and 3 are not the same, so I can't use those, but I see y and y. Same number, same sign. So the first thing I'm going to do is rewrite this equation, changing all the signs. Okay? So basically what I'm doing is multiplying by negative 1. This sign, negative 2x, changes to positive 2x. Negative y changes to positive y. And positive 6 changes to negative 6. All I've done is change every single sign in the problem. The second one, I'm just going to copy. Negative 3x minus y equals 10. Now when I look, I've changed it so that these ones have opposite signs. So when I add 2x minus 3x gives me negative x. These cancel. Negative 6 plus 10 is negative 4. Actually, that's positive 4. Sorry about that. Negative 6 plus 10. The 10 has a larger absolute value. So I'll divide both sides by negative 1, and I get x equals negative 4. I'm not done. I have to go back and plug it in to one of these equations. So negative 2 times negative 4 minus y equals 6. 8 minus y equals 6. I will subtract 8 from both sides. There are a lot of negative signs in this problem. Again, I'm going to divide by negative 1, and y equals 2. So my answer would be negative 4, 2. To double check, I could plug it back in. I would get 8 minus 2 equals 6, or I would get 12 minus 2 equals 10. Both are good statements. So just one more example. 3 and 5, not the same number, can't use them right now. 6 and 6, they are the same number, but they have the same sign. So the first one, I'm just going to change all of the signs in the entire problem. And the second one, I copied directly across without changing any signs. Now I have the same number opposite signs. When I add these equations, I get negative 8x equals 16, negative 16, and x equals 2. I will go back and plug that into this other equation. 3 times 2 plus 6y equals 48. 6 plus 6y equals 48. 6y equals 42, and y equals 7 for an answer of 2, 7. So those are the steps to solve by elimination. Step number 1, we'll add another step tomorrow, but these are the basic steps. You choose which number to eliminate, choose which variable to eliminate. If they have the same sign, multiply an equation by negative 1, which just means change all the signs. If they have opposite signs, or once they have opposite signs, then you add the two equations. Finally, you substitute the solution into either equation and solve for the other variable.